In today's notes, we're going to review quadratic word problems. So you did see this back in Algebra 2. What I'm going to do is I'm going to show you not only how to solve these questions again, what terminology and terms to look for to help you solve, but I'll also help you with how to substitute or plug these things in to your graphing calculator. So you want to have the graphing calculator next to you, the TI Inspire. If you don't have the Inspire, please pause the video so you can get that calculator. So let's start out by looking at example 1. So in example 1, it says a fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by g of x equals negative 16x squared plus 64x plus 80. You need to find what is the maximum height. Okay, I keep seeing this word maximum. So I know it's going to take you some bits since we're in pre-cal now, but take a little trip down memory lane into Algebra 2. When you think of the word maximum, that is talking about if I was to graph this out, which we will do. If I was to graph this out, the maximum height would mean it's literally the highest point. That's your maximum, pretty much your maximum, not just the height, because technically your maximum is a coordinate with two values. So I need to find out what that maximum piece is. So I need to really find out what that top point is. What is another name for that top point on your parabola? Begins with a V. This is the same thing as your vertex. So when you're finding the vertex, that's an H and K value that you need to use to find that maximum value. So what I'm going to do is I'm going to show you how to do this in your calculator. If you think back to Algebra 2, or if you look back to your notes in Algebra 2, you should know how to solve this by hand. That requires using the axis of symmetry and then plugging that axis of symmetry back into g of x. So let's go ahead and identify what your maximum height is going to be. So I'll just do a trip from memory lane really quick and I'll find it algebraically. And then I'll show you guys how to use your graphing calculator. I won't do the algebraically for every question, but I at least want to refresh your memory as to where you've seen this before. So when you're finding the maximum, the first step you want to use is your axis of symmetry, if I can spell it correctly. So when you're finding your axis of symmetry, that's the equation x equals negative b over 2a. So in this equation that I have here, I have my a, I have my b, and I have my c. So if I'm going to substitute this in, I'm going to do negative b over 2 times a. So if I was to simplify, negative times 64 is negative 64. Negative 16 times 2 is negative 32. And then from here, all I need to do is divide. So if I was to divide 64 by 32, I should get positive 2. As I just said a second ago, after you find those two values, or that value for the axis of symmetry, what you have to do now is you need to substitute it into g of x. So substitute into g of x. So that means I need to take this 2 that I just found and substitute it in this equation for every x that we see. So we're going to have y equals negative 16 times 2 squared plus 64 times 2 plus 80. So, especially since you have a brain and you can solve this, definitely solve it really quickly. So we're going to have negative 16 times 4 plus 64 times 2 plus 80. 16 times 4 is going to give me 64, negative 64. 64 times 2 is going to give me positive 128, and then I'll add 80. So if I was to combine all of that, 128 plus 80, and we're going to subtract 64, I'm going to get positive 144. So I know we solved this by hand. I am going to show you guys how to use your graphing calculator to do this, but I want to really quickly talk about what these two values mean. Well, if you think about the axis of symmetry is the x value for your vertex. So if I was to write this out as a coordinate, it would be 2, 144. So if you're looking at the equation itself, let me read it again. It says the rocket's height above is represented by this equation. So when you're looking at that rocket's height, that's talking about the g of x. That's talking about the y value. So the height that I'm trying to get to is this y value. Think about it. What does the x represent? Read the problem. What does the x represent? Especially for this question, x is more than likely going to represent the time. And we did that a lot back in Algebra 2. Anytime you're looking at time, that's usually representative of your x value. So the answer that I'm technically looking for your maximum height is 144 feet. That's the max height. If it asked me for the maximum time, I could tell you 2. But since it's not asking me for the time, I'm just going to leave my answer like this. Remember, I'm going to show you how to do this in your calculator. You won't always need to use this method by hand, but I'm saying just in case you either ran out of time and it's on a calculator portion, or if you really just remember how to use by hand instead of using the calculator, you'll always be able to find your answer. Okay, so let me get your calculator on the screen, and this is your TI Inspire. And on this calculator, the first thing you want to do is go to Add Calculator. So let me first reset this whole thing just to make sure. So I'm going to go into Browse, which I think on yours is My Documents. So go to My Documents, which is option 2. We're going to hit Enter. We're going to push the menu button. We're going to scroll all the way down until we get to C, which is Delete All. It's going to ask, do you wish to proceed? You're going to scroll over and hit OK, which is this button here. It won't let me do it because it's on my computer. Then once you hit OK, it should say, come back to the main screen, and it'll say that you guys have cleared your calculator. Let me cancel this and back to the main screen. Okay, so we've started from scratch. We have our whole calculator reset. We're going to go into a new document, and I want to graph this. We're not going to use the calculator function just yet. We're going to use the graph function. So in the graph function, I'm going to take the equation. So look at your paper, the negative 16x squared plus 64x plus 80, and we're going to use that to graph. So on your calculator, follow my mouse. We're going to use negative 16x squared. Here's the squared button, plus 64x plus 80. Not minus, plus 80. And we're going to hit enter. What this has done for me is it has graphed the entire function. It's only showing these two sides. However, keep in mind this graph will go all the way, pretty much really way up high, all the way up to the top, and then it'll come back down. You look at the Y window, we're only at about 7 units. So that's why if you think of what we just solved mathematically, we should be seeing that at almost over 100, almost at 150 pounds. So pretty close to 150, or not pounds, feet. So what I need to do is try to figure out what the maximum height is. The worksheet that you guys have is actually very helpful because it keeps telling you the maximum height. What you're going to do now is you're going to go into menu after your graph is drawn. You're going to scroll down to option 6, which is Analyze Graph. And we're going to go to that word maximum, which is number 3. So we're going to scroll down. Let me go back to where I was. Scroll over and then down to maximum. This guy here. So with maximum, I need to hit enter, and it's going to ask you for 2 things. It's going to ask you for your lower bound and for your upper bound. So once you're on the far left side of the graph, so literally just put the entire graph in this window. So look at my screen so you can see what I'm doing. I'm going to start from the left-hand side. I'm literally just going to hit enter, and I'm going to scroll all the way over to get to my upper bound and hit enter again. Notice at the very top, it says my maximum, which is this guy here. So before I put my mouse on the screen, it showed you your maximum coordinate. So right now, make sure you can do that. So do that really quickly while I'm writing on my screen. And I want to make sure you get that exact same point. So hopefully you got it. If you didn't, pause the video, let me know. If you look back on the screen that we have here, the coordinate that I have is the maximum of 2, 144. The only thing you need to keep in mind, because sometimes I could easily put a letter E and put just 2 feet here. Make sure you understand which one is which. The X column for this coordinate is the time, and the Y column for this coordinate is the feet. So make sure that when you are finding these that you know what the coordinate represents, because if you get the coordinate, cool, but you need to be able to interpret it. So I'm going to do 2 things. I'm going to circle my answer as D, and I'm also going to make a note over here that X is the time and Y is the feet. So that's the units that I would want to use. So that way, whenever you're doing the next question, you know what to do. So right now I want you guys to try to do example number 5. So flip the paper over, pause the video, and try to do question number 5 right now. So for question number 5, this is worded a little differently, but you have knowledge of Algebra 2. So if you didn't pause this video and you're just expecting me to go through it, you're doing yourself a disservice. You're not going to be able to do this on your tests and quizzes. So this one says, in an effort to catch a criminal, a superhero is going to leap over a building to take a shortcut down the alley. The function f of x equals negative 16x squared plus 150x gives a superhero's height in feet as a function of time. The building is 420 feet high. Will the superhero make it over the building? Okay, this problem I really like a lot better because it actually describes what you have. So for this function of x, it specifically says this is the superhero's height in feet as a function of time. So that f of x that you see, the x inside the parentheses represents the time again, and the f of x, the entire f of x, represents the superhero's height. So every x that you see here, these are the times. The f of x represents the superhero's height. So I'm going to write that out. X is the time. Y, which is f of x, is going to be the superhero's height. Okay, again, we could do this by hand. I already showed you one example to do this by hand. That was a trip down memory lane. Let's use your calculator to try to figure this problem out. So I want to see if the superhero is going to clear a building that's 425 feet high. Okay, well, let's figure out what your vertex is first. Let me move my calculator over, get your calculator out. I don't like to necessarily have you keep resetting the calculator to clear this out, and I don't like you having to use the same document. So for me personally, at least for my class, until we use this more, just add a new page. So over here, I'm going to hit Control and Doc, and it's literally going to add a brand new page. I'm going to scroll down to option 2, enter, and I have a brand new clean graph. So let's go ahead and type this in. We're going to do negative 16x squared plus 50x. And I'm going to, not 50, 150. Make sure that looks like my equation, negative 16x squared plus 150x. Beautiful. Hit enter. It did the exact same thing. So all I need to do now is make sure that it reaches a maximum height that hopefully is 425 feet. So again, we need to find, if you're looking at this problem, you want to find that maximum height again. So what is his maximum height? Because we want to see if it'll be over 425 feet. So I'm going to hit Menu. I'm going to scroll down to option 6, which is Analyze Graph. And we're going to go down to option 3, which is Maximum. Enter. I'm going to do the same thing that I did before. So this time I have to scroll. There we go. To scroll my line over here. I can kind of cheat, guys, because my screen is pretty doable, but you guys are going to have to use these arrows over here. So I'm just going to kind of go here, all the way over to here, and it gives me my maximum. So let me write my maximum down on my paper. So we're going to have 4.69, 352. All right, so let me move this back to my screen. And let's examine this. So we already said before that x represents your time, and 352 represents the height. That's my y value. So if I was looking at the height for this, that means that given this function, it looks like the superhero is going to reach a height of about 352 feet. Oh, okay, well, if I read the problem again, it says the building is 420 feet high. If at the maximum, that's the highest point, guys, think back to maximum. If I was to draw this graph out, my maximum height is this height here. If 425 is up here, is he going to reach that height? There's literally a gap. There's not that much space. So what I probably am going to need to do for this is not be able to reach that height. I'm sorry, superhero, you're not going to be able to get there. Unfortunately, he's only going to reach 352 feet, so C would be your best answer. Nope, unfortunately, he's going to crash into the building at 351 feet. On your calculator, it rounded up. The exact decimal is about 351.56. So if you solve this by hand, you'd get it closer to C. But honestly, I wouldn't give you guys that close of a number between 351 and 352. All right. Let's look at 2 more questions, and then the rest of this page will be extra practice for you. It's really good extra practice for you to review. All right, let's look at example 2. For example 2, this says a fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by negative g of x, which equals negative 16x squared plus 64x plus 80. It asks you how long will it take the rocket to hit the lake. Okay, well, if you think back to the question that we just did, it looks very similar to it, but it's asking a different question. So on the question before, for the exact same equation, it's asking for its maximum height for this question here, maximum height. For this exact same equation now, it's asking when it's going to hit the lake. On a test or quiz, as an answer choice E by chance, I might put 2 seconds. And if you're thinking back, why is that 2 seconds relevant? Okay, well, if you think back to the last question, that's the time that it took you to reach your maximum height. So let me ask you, I keep seeing the word maximum height here. Is this question asking about the maximum? No, this question is not asking about the maximum. It says that it reaches its maximum height, but the problem itself says, how long will it take for the rocket to hit the lake? How long? That's time. Hence why all of your answers are in seconds. And it's also asking when it will hit the lake. Okay, well, the maximum was above. That's not what it's asking. Hitting the lake is when it's going to come back down. So let me kind of draw this out. When it's going to come back down and hit pretty much the surface of the lake. Okay, well, if it's starting from a hill and it goes down, so let's say that's the hill, it's going all the way down, this will be when it hits the lake. What is that? That point that I'm pointing at, what is that? This is your x-intercept. Having your x-intercept means you cannot use the vertex anymore. You have to actually find where it intercepts the y or the x-axis. So what I'm going to do is I'm actually going to do this by hand. Anytime you're finding the x-intercept, you want to make sure that you take the given equation and set it equal to 0. If it's going to hit the x-axis, this is where 0 is on the x-intercepts. So you always want to have that equal to 0. Okay, let's solve. I actually can factor this, so I kind of know what I'm doing here. So if you want to use your calculator to kind of get some numbers to help you with the factoring piece, we will graph this to show you what it looks like. For right now, if you want to hit Control, Doc, and Add Calculator, you can do this to do the calculations to divide and simplify. So actually, you know what? Y'all pause the video right now and factor this problem. This will be good practice. Okay, so if I look at this and I want to determine the time, does it make sense to have negative time? No, it doesn't. So my only answer that I should be able to use for this is positive 5. So A should be my answer. Okay, let me show you how to do this in your calculator to make sure you know how to graph this if given the opportunity, because it is a lot quicker than having to factor or to figure out if you can factor. So hopefully you have some calculations here. I'm going to add a new graph, so option 2, and I'm going to take that same equation, negative 16x squared plus 64x plus 80, and I'm going to graph that again. I know I already graphed it at the very beginning, but I kind of just like having a clean slate every time, so it's up to you. But I would definitely recommend just using a clean slate every time, because especially for this question, we're not looking at any maximum points or anything. We're just looking at the x-intercepts. So let me put 64x plus 80. Graph. And remember, I want to find the x-intercept. If you look at the kind of sketch that I made, I want to find this farthest x-intercept, because remember, we can't have negative time. So on here, I have my negative time. That's irrelevant. I don't need it. I do need this time, however. It looks like it's directly on that point of 5. So it looks like it's at 5, but I can also use my menu to help me as well. So use that menu to your advantage. So let me hit menu. I'm going to scroll all the way down to Analyze Graph. And we're going to hit, think about it, guys. What's another word for x-intercept? Hopefully I'll remember 0. 0 is another term for x-intercept. So I'm going to hit enter for 0, and it's going to ask me to do the same thing. I need my lower bound and my upper bound. For this question, look at my calculator. I'm going to use, after this actual lower number, after -1, I'm going to kind of go inside of the graph to hit enter because I only want it to calculate the right-hand side, the positive x-intercept, because the -1 is not going to help. Ooh, looks like my x-intercept is already there. My 0, which is my x-intercept, is at 5, 0. So my 0 is at 5, 0. And again, that's my x-intercept. So I'm just making a note on your paper before I move it. So make sure you guys can scroll that graph over so you can see what you got. And I have my x-intercept clearly labeled. So remember, what your x-intercept means is after 5 seconds, you are at 0 feet, which is the x-intercept. So right now, you guys try example 3. Okay, for this question, it's saying a rock is thrown from the top of a tall building. The distance in feet between the rock and the ground x seconds after it's thrown is given by the equation. How long after the rock is thrown is it 340 feet from the ground? Okay, this one's a little different. It's no longer asking when it will hit pretty much the surface. It's not asking when it's going to hit the ground. It's not asking when it's going to hit a lake. It's asking when is it going to reach 340 feet. So what I'm going to do is I'm going to reuse the f of x equals -16x squared minus 4x plus 382. And for 340, there's only 2 places to plug this in, guys. You tell me. Do I plug it in here for the entire f of x, or do I plug it in here for each of the x's? Think back to what we just read. The distance in feet between the rock and x in seconds. X represents time. Do not plug 340 in for both of these x's. Do not do that. Instead, replace the entire f of x with 340. That is the height that we want to get to. So 340 equals -16x squared minus 4x plus 382. This is what you should have solved. Unfortunately, you can't just plug this in. At least I don't want you guys to just plug this in because it's not equal to 0, or it's not just equal to some value. So especially for questions that we plug into the calculator where we're trying to find a specific length, you definitely want it to either equal like f of x or y or equal to 0. So what I'm going to do is I'm going to subtract 340 on each side. So we're going to have 0 equals -16x squared minus 4x plus, if you subtract those numbers, you'll get 42. And you could technically factor this or use quadratic formula, because keep in mind, if you can't solve it by hand, you can always use quadratic formula. Let me use my calculator instead and try to figure out what my answer is going to look like. Let me scroll this over. I'm going to again get a new document. I'm going to graph it. We're going to do -16x squared minus 4x plus 42. Okay, I have my graph. And again, this one is asking when I'm going to hit 340 feet. So instead of me actually trying to scroll up to find 340 feet on the y-axis, what I've already done here is I've pretty much made it into like my x-intercept. So by finding what the x-intercept is on the right-hand side, because remember, negative x-intercepts are useless, finding this x-intercept, I'm actually finding the time at 340 seconds. So I'm going to go ahead and hit menu, analyze my graph. Let's find another 0 because this is another x-intercept. I'm going to scroll over. Oh no, that's going too slow. We're going to go from here to here, and that's at about 1.5 seconds. So we write that coordinate out, 1.5, 0. This is my time, and that is in seconds. So over here to the side, my b value is 1.5, or not b, but my height that it's or the time that it'll reach whenever it's at 340 feet is at 100 or 1.5 seconds. I don't know why I'm trying to make these hundreds. So with these questions, make sure that you guys actually attempt at least a few more before you put your calculator away. These questions will be very helpful, especially when you're trying to track the projectile motion of an object. One last thing that I do want to mention, if you want to actually see what this curve looks like, what we can do is zoom out. So that's the last thing we'll do before I have you pack up. So with the menu, I'm going to zoom out. I'm going to hit go to 4, which is zoom. So I should have gone down to 4. And I'm going to go down here to option 4, which is zoom out. And what you're going to do is you're going to position your little magnifying glass in the center of your graph at the origin. And you're just going to keep hitting enter until you see the very top of that graph. As you get farther out, it's going to become more distorted, but this is the projectile motion that your graph will have. It starts up, reaches its maximum height, and it comes down. And you can honestly do that for any graph that you have. So any graph, you can actually zoom out. And as you kind of have bigger and bigger graphs, it kind of gets thinner and thinner as you zoom out. This is kind of what your projectile motion looks like, which is the same thing that I graphed on these questions here. So it's the same projectile motion. If you guys have any questions, please let me know.